Hello and welcome to another video. Today we're going to be doing 328 odd even linked list. So given the head of a singly linked list, we want to group all the nodes with odd indices together, followed by the nodes with the even indices, and return the preordered list. Okay, that makes sense. The first node is considered odd, the second node is considered even, and so on. So, okay, we have like the relative order inside both even and odd groups should remain as it was in the input, and you must solve the problem in O of 1 extra space and O of n time. Okay, so we're given this example here. What we have is 1, 2, 3, 4, 5. This turns into 1, 3, 5, 2, 4. So, okay, all the nodes with odd indices together, followed by all the nodes with in. So 1, 3, 5, and then 2, 4. That makes sense. Same thing with this 1, 2, 3, 6, 7, 1, 5, 4. Okay, that seems to be simple enough. I guess my thought is I guess we have to traverse the linked list in some sort of a way. So one, like a traverse linked list, and we have to separate the nodes into two different groups, odd and even, like it says in the problem. I guess what we also need to do is, in order to do that, we'd probably want to maintain two pointers, because we have like one at the start and like one like at the like for like one for odd and one for even. So what we could do is we could have two pointers for that, and then we can like link the two groups together at the end, and we link together at the ends. And then from there, what we could do is with these two pointers, what we could like just like iterate through over for every single one, and just traverse through to ensure what happens. Yeah, so yeah, we could, first of all, we can initialize the odd and the even pointers. So initialize um, initialize odd and even pointers here. And then from like the odd or even pointers, what we can do is we can store like the start of the even nodes to like later just connect. So store the starts of even nodes to later connect together. What we could do after that is just pretty much like iterate through, like while like even exists, just iterate through list, and just figure it out until like the until either like the odd or the even reaches the end. What we would then do is like if we encounter a node that's odd, we would just connect the odd node. So if we encounter an odd node, we'd connect it to like the next odd one, and then same thing with the like the even. If we connect an even node, we connect it to the next. So, and then we would just do it in that sort of way. So we remove the even pointer to the next even node if we are able to do that. And at the end, we just connect the two nodes together. So connect the two nodes together. So I guess that's kind of the idea. So just traverse the linked list with an odd and even pointer. We have like this, we figure out what the start of the nodes are so we can later connect them together from there. Then we iterate through just connecting the odd with the odd and the even with the even, and then we can return that at the very end. So if that kind of makes sense, I can go ahead and begin implementing it now. So we can have the odd even list over here. I guess like the first thing we need to do is we need to check to see if like there's not like a check to see if the list is empty in the first place, I'm guessing, because that's going to be like one of the cases. So if not head or not head dot next, then we want to return the head. So return head. So the next thing we want to do is we want to initialize the odd and even pointers, so which we can later add back to the end. So odd is equal to head, and then even is equal to head dot next. From there, what we can do is we can store the start of the even nodes to connect them later on. So even head is going to be equal to even. From here, what we could do is we could then iterate through the list until all of them, either like the odd or even reaches the end. So while even and even dot next, we can go ahead and connect the old one to the next, or not the old, the odd node to the next odd node. So we'll do odd.next is equal to evens next, I guess, because evens next is going to be what's connected to the next node. So even.next. Then we can go ahead and move the odd pointer to the next odd node. So odd equals odd.next over there. And then what we can do from there is connect the even node to the next even node. And we know the next even node is going to be odd.next. So we do even.next is going to be equal to odd.next. And at the very end, we want to do even to equal even. Want even to be equal to even.next over here. So yeah, if that makes sense. Next thing we need to do is actually connect the last odd node to the head of the even node. So we want to do odd.next is going to be equal to even head. So that's what's going to actually connect the linked list together. And then after, at the very end, we can go ahead and return the head. So return the head over here, and we can go ahead and run this. It's accepted. Go through this, and all test cases passed. So to do like a little bit of a further explanation, the time complexity is O of n because you kind of iterate through every single the list once, and yeah, so that's what causes it to be O of n. And the space complexity is O of 1 because you're not really storing anything in additional data structures. It remains that way. So yeah, that should be the problem completed.